Hello, everyone. This is the Morningstar Institute 2022 Winter Week 1 Day 1 Solution videos. Problem 1. Fold a square paper 3 times according to the directions to form a triangle. Then cut the triangle along the dotted line and unfold it. Which figure will you get then? So for this problem, we have to just do experiments to fold with paper to see which one we will get. So right now we have a square piece of paper, as you can see in my video, and we're going to follow the directions to see which shape we can fold. So first of all, from the first direction, it says to fold from the bottom to the top as the arrow states. So we're going to do that from the bottom to the top. I'm just going to do off camera to make it easier. And then the crease should be at the bottom, as you can see. And then it says to fold from left to right. So again, we're going to do that from left to right. And make sure to follow these directions very carefully because you could easily just do it very wrong. And finally, from the third direction, it says to fold from the top to the bottom. So we're going to do that. And finally, you should end up with a triangle looking like this. And now we're going to draw a line, the dotted line, to cut along it, like right here. So we're going to cut it. And now let's see what shape we will get when we unfold it. As you can see, we have just folded number C. So your answer for this problem should be C because it looks exactly like it. Now for problem 2, which of the following nets cannot be folded into a cube? So for this problem, you basically just have to fold each one of these or just draw lines to connect these cubes together and just play around with these cubes until you get a cube. One of these 5 nets cannot be folded into a cube, and it shouldn't take long before you can find out that the one that cannot be folded into a cube should be D. So D cannot be folded into a cube. So for problem 2, you just need to play around with the nets. Problem 3. The following is a figure that consists of 7 pieces of Legos. Step 1, move one piece to form a rectangle. Step 2, then move one piece to form a parallelogram. Step 3, finally move one piece to form a trapezoid. And just so you know, this, as my color, this is a parallelogram. And this green is a trapezoid, just so you know. All right, now let's start with step 1. Move one piece to form a rectangle. As you can see, there is an extra triangle sticking out as this orange draws. So we can move this orange over here, this spot. So we can erase this one triangle and move it here. So right now, you're basically just eliminating the right triangle and putting it over here to form a rectangle, as you can see. Step 2, then move one piece to form a parallelogram. Well, right now, what we should do is basically move this number 2 triangle and move it over here so that we form a parallelogram like this, as my yellow highlights. And now, finally, step 3, move one piece to form a trapezoid. What we can do for this step is just very simple, just to flip the left triangle and make it so that this triangle is now, the bottom is now facing like this. So once we have flipped it, we should get something like a trapezoid like this. Problem 4. How many squares in the following figure contain the Pikachu? So first of all, we can see that the middle square has the Pikachu. So this is 1 right there, middle square. And then let's go to the larger squares. We can see that this larger square in orange also has the Pikachu. So that's another 1. So 2 tallies. And then from the black, we can also see that this black square that I'm overlighting right now also contains the Pikachu. And then we can see that another large square in blue also has the Pikachu. And finally, another square in yellow also contains the Pikachu. And in total, this should be 5 tallies. But then lastly, there's also this huge square that contains the Pikachu. So that's one final tally. And now let's count up the tallies. We have 1, 2, 3, 4, 5, and 6, as you can count right here. So in total, 6 squares in the following figure contain the Pikachu. This is Winter Week 1, Day 2 solution video. Problem 1. Cut a paper square along its diagonal to have 2 triangles, which are 2 right triangles with 90 degrees angle. Which of the following figures can be formed by putting these 2 triangles together without overlap? So let's look at the first case. We have 3 cases in total. Let's see which ones can be put together without overlap. Let's first split the first right triangle into 2. And as we can see, this splits into 2 90-degree right triangles. So we know that when you cut a paper square along its diagonal, you get 2 right triangles. And as you can see here, we have just split it into 2 right triangles. So we know that the first one can be accomplished. The second one, let's see if it can work. We can split it into 2. And again, we can see that we have a 90-degree angle and a 90-degree angle. So we know that the parallelogram can work too. And another way of seeing this is that when we have a right triangle like this, we can also add an upside down triangle like this, and this forms a parallelogram. Let's look at the third one though. Let's see if it works. We have, again, 2 right triangles, but as you can see, we have this massive chunk of this rectangle in the middle that's not quite there. So you have overlap. So therefore, this cannot work. So therefore, we have only 2 cases, the right triangle and the parallelogram, that can work. Now moving on to problem 2. Here are 3 shapes. Which of the shapes below cannot be obtained by turning around, but not over one of the following shapes? So as you can see right here, we have 5 different cases. Let's start off with case 1. Case 1, you can see that it can be accomplished by twisting around the first figure. B can also be accomplished by turning around clockwise to the second one. And C can be accomplished by turning to the right from the first figure. However, D, as you can see, D cannot be accomplished just by turning around. However, D can be accomplished by flipping over from the third figure, but as you can see, that is not allowed. So therefore, D cannot be obtained by turning around. Problem 3. Which of the following can be folded to make a square-based pyramid? So for this problem, you can just carve out one of the shapes and try to experiment with it in order to make a square-based pyramid. So for example, I just carved out number B, and now let's see if we can make a square-based pyramid using B. So I'm going to fold it off camera just to make it easier. Okay, let's see if we can make it. Let's see. And yes, B can be folded to make a square-based pyramid, as I have just made it look square-based. See, all sides are of square-based pyramid. This is a pyramid. So yes, the answer should be B because I have just carved it out with a square base. So the answer should be B. B can be accomplished to make a square-based pyramid. Finally, problem 4. According to the pattern, draw the mystic figure on the third line. So for this problem, we need to figure out the pattern. And there are many ways to do this, but I'm just going to do the one that's most straightforward. On the first one, we see that there is 1/4 of a circle. And then what we're going to do is combine all of these into making one circle. So let me show you how to do it. First of all, you're going to move 2 of these over here so you can fill it up. And as you can see, miraculously, you can also move this over here to complete one full circle. So, and the same thing can be said for the second one. You can drag these two over here with order, of course, and you can fill it up. Well, let me use a different color. Okay, so you can drag these over here with the order, and you can drag this over here as well and complete the figure, complete the entire figure. So the same thing is the same pattern on the third one. So we're going to draw this out again and move all of these over here. So you're going to fill this up and then moving this over here and this over here. You're just going to fill these up. And what's left is this part. So we now know that the missing figure should be something like this when given the pattern. This is the winter week 1, day 3 solution video. Problem 1. The following is a 3-dimensional figure that consists of cubes of side length 1. To form a rectangular box, at least how many more cubes do you need? First of all, the rectangular box that we need to form is shown on the left here. Now, all we need to do is just fill in the cubes on the right. So this is 1 cube. This is 2 cube. This is 3 cubes. And this is 4 cubes. So again, let's count that using this black. 1, 2, 3, the last one, 4. So in total, you need at least 4 more cubes to form a rectangular box. Problem 2. According to the pattern in the first line, which of the 4 pictures from 1 to 4 in the second line should be put on the question mark position? So in order to solve this problem, we need to find out the pattern first. As you can see from this above pattern right here, we can easily note that 1 dot replaces 1 line. And then in this third picture on the top right here, you can see that 2 dots replace 2 lines. But this is not just some random pattern. This pattern is going in counterclockwise. So given this information, if it continues to replace lines using counterclockwise, then the next line should just be like this because it's going counterclockwise. So which of these 4 following matches the figure that we just drew? Of course, it is just 2. 2 should be written on the question mark position. Problem 3. Jillian is standing inside a pet shop and looking out the window shown in the diagram. We see that the shop says pet shop. So what does she see when she looks out the window? So as we know, when you look outside a mirror, you see the reflection. So all you have to do is just experiment with a piece of paper and look behind it, and that is the reflection. For example, as I have just wrote right here, this is the pet shop, and all I have to do is look behind it like this and see what I see and find it right here. And you can see that we have just found out the answer, which is E. Finally, problem 4. Mara built a square by using 4 of the following 5 shapes, A to E. Which shape was not used? So let's do A first. A, let's find it inside here, the square, and oh, we just see it. It's right here because it matches up perfectly. It's 3 stars and 1 diamond. And as you can see, that matches up perfectly. So this is A. Moving on to B, let's find B inside the square. We can see that this matches up to B because it has 1 circle and 3 diamonds exactly like B. And moving on to C, let's see which figure has 1 circle and 2 stars. Well, of course, it's just right here. And what's left with, oh, we can just see that it's, of course, E because it has exactly 3 arrows and 2 circles, which leaves us with D because there is no more room inside the square. So the answer should be D. D was not used. This is the winter week 1, day 4 solution video. Problem 1. Eric has 4 bricks. Which of the cubes shown below can he make with his 4 bricks? For this problem, all we have to do is to play around with these 5 cases. And once you have done that, we know that the answer must be C, and it's pretty obvious too, because with the others, you only have 2 of these black bricks. As you can see from A, for example, you have one here and one here, whereas on B, you have one here, on D, you have one here, and on E, you have one here. While he has 3 black bricks, and the only cube with 3 black bricks is C. So it's pretty obvious that the answer should be C. Problem 2, place 3 circles on the third picture by the pattern. So for the first case, you see that we have 3 circles placed horizontally. For the second, we have these 3 squares placed like this. Then we are shown the pattern is that every time we have another picture, one of the circles moves to the right. And once it goes to the right, then it just jumps back as shown right here by my green arrow. Once it reaches the end, then it just goes right back. So now let's test it out. The first row, if it's on the second column, then from the third picture, it should be on the third column. And if the second row circle is on the third column, then right now it should be on the first column in the second row. And finally, the bottom row, if it's on the first column, then on the third picture, it should be on the second column. So it should look something like this. Problem 3. Which one of the following shapes has a line of symmetry? If you fold a shape along this line of symmetry, 2 parts will match up. So what is symmetry first? For example, if you fold a square in half, then that crease will be its line of symmetry, and the 2 parts will match up if it's symmetric. Take my square, for example. If you fold it in half, and you will see that this square is symmetric because its crease is the line of symmetry, and the 2 parts exactly match up like this. So returning to the problem, we have 5 choices and we need to find out which one is symmetric. And after going over and testing out each shape, we should get that this triangle in A right here is symmetric because when you fold it in half, these 2 parts will match up. So therefore, the answer should be A. Problem 4. Which of the following pictures is different from the others? 2 pictures are considered the same if one can be obtained by a suitable rotation of the other. So let's look at the first one. We know that the first one cannot be the same as the second one because these small triangles are on the same exact spot, but the black part is not. So therefore, we know that one of these 2 has to be the answer. Then we move on to the third one. Let's see what the third one matches. And once you play around with these 2 cases in the beginning, you can find out that this third case matches up with the first one. And the same goes for the fourth one. If you just rotate it 2 more times, then you end up with the fourth case. And the only one that we're left with is the second one. So therefore, the second one is different from the others. Hello everyone, this is the Winter Week 1 Day 5 solution video. Problem 1, draw the 6 missing figures in the following sequence. So as we can see, we start off with 1 square and 1 circle. And then we have 2 squares and 1 circle. And then we have 3 squares in 1 circle. So then we can see the pattern is just 1, 2, 3. The squares are increasing by 1 every time, while the circles are staying the same. So we know that the first 4 question marks should all be squares. And then the 5th question mark should be a circle. And then after that, the 6th question mark should just be a square. So it's square, 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 circle, square. Problem 2. Below are 2 pieces of paper of different shapes. Find a way to cut the left figure into 2 parts and put the parts together to form the right figure. So again, you should just play around with the figures, and eventually we should know that once you cut the left figure like this, and then move all the figures down here. For example, this should go right here, that, and then the top 2 should go like this. And finally, the bottom three should go right here. And yeah, that's basically how you do it, like this. And as you can see, it's still the same figure. And then we just formed a square. Problem 3, which of the shaded areas below is the largest? So for this problem, we can just count out the figures. We know that one triangle plus another triangle, hence right triangles, are equal to one square. So just keep that in mind. For A, we know that A has 1, 2, 3, 4 right triangles, which equals to 2 squares. And then let's count out the squares that A has. 1, 2, 3, 4, 5, 6. So 2 squares plus 6 squares equals to 8 squares. So we know that A is 8 squares. Now for B. B has 1, 2, 3 right triangles. 3 right triangles equals to 1 square plus 1 extra triangle. And now let's count out how many squares it has. 1, 2, 3, 4. So it has 4 squares. The 1 square plus right triangle plus 4 squares is equal to 5 squares plus 1 extra triangle. So therefore, it should be 5 squares plus 1 triangle. And now let's do C. Let me just erase this for convenience. We have 1, 2, 3, 4, 5, 6 right triangles equals, and that is equal to 3 squares. So yeah. And now let's count up the squares that C has. 1, 2, 3, 4. So 3 squares plus 4 squares is equal to 7 squares. So therefore, C has 7 squares. Now let's do D. D, let's count out how many triangles D has. 1, 2, 3, 4, 5, 6, 7, 8 squares. I mean, 8 triangles should be equivalent to 4 squares. And now let's count up the squares that D has. 1 and only 2. So 4 squares plus 2 squares is equal to 6 squares. So therefore, D is 6 squares. And finally, we come to E. Let's count out how many triangles E has. 1, 2, 3, 4, 5. So E has 5 triangles, which equal to 2 squares plus 1 extra triangle. And now let's count up how many squares E has. 1, 2, 3, 4, 5. So 2 squares plus 1 triangle plus 5 squares is equal to 7 squares plus 1 triangle. So therefore, we can just write out 7 squares plus 1 triangle. After looking at these results, we can safely say that the largest shaded area should be A. So A has the largest shaded area. Problem 4, 18 cubes are colored white or gray or black and are arranged as shown. The figures below show the white and the black parts. Which of the following is the gray part? So just playing around with these figures, we can see that this figure has 2 layers. The top layer is all black and 2 whites. As you can see, and the 2 whites are from here. And then you have the leftover remaining 2 whites on the bottom, and these 2 whites should be connected to the gray parts together. And then as you can see already, this should only be E because it connects just fine right here. So the answer should be E.